Okay, in this video we're going to solve a second order circuit here. We need to write our differential equation down, and in order to do that we need to figure out if it's going to be RLC series or RLC parallel. So let's see what happens after the switch opens. So I've got my resistor here, I've got my capacitor. The switch opening is going to make this middle part not be connected. And if it's not connected, we basically don't need it all. That 6 ohm resistor, nothing's ever going to happen because no current is going to be able to go through it. So I might as well just not even draw it down. And then I have my inductor here. And so we see this is going to be an RLC series circuit. So we know for RLC series that the default equation is x double prime plus r over L x prime plus 1 over LCx equals some constant here. And in particular, in this case, we are trying to find the current through RLC series. So that is this most special version of this equation because we know for DC sources that the right side is going to be 0. So we go ahead and plug in what we have. My R is 3. Let me write that over here. 1 farad, 2 henries. So my R over L is 3 over 2. That's going to be 1.5 I prime. And then my 1 over LC is 1 over 1 times 2 is going to be 1/2, or 0.5 I equals 0, which means I get my default auxiliary equation, s squared plus 1.5s plus 0.5 equals 0. Now at first you'd probably say, well, we can't factor this, it's going to be quadratic formula, but you actually can factor this as s plus 0.5, s plus 1. Which means we get two answers here. One is negative 0.5, one is negative 1. So then we can write down our solution is k1 e to the negative 0.5t plus k2 e to the negative 1t. And normally we'd have plus a constant here. But again, we know that if it's the current for RLC series, then it's going to be plus 0 there. And if you don't like that, you can see what happens as you go to infinity. Well, it means we're in steady state here. So the capacitor becomes an open, inductor becomes a short. And what is the current at infinity? That's 0. So that's why you don't have to add any number there. Now to figure out our K1 and K2, we need our initial conditions. So for that, we need to look at what's happening right before the switch goes. So at t equals 0 minus, we're in steady state. We have the 12-volt source hooked up. We have inductor as a short. Now because of the capacitor on the left branch, it becomes an open, no currents flowing there, which means we just have this current going this way, and 12 over 6 is 2 amps. So my current through my inductor, which is kind of in hiding here, that's going to be 2 amps. And we can also find the voltage. Well, the voltage across here is going to be the same as the voltage at the top node. Since there's no current going through the 3 ohm resistor, there's no voltage drop for the 3 ohm resistor. So that's why the voltage is the same there. However, if you look at this 12-volt source here, and 2 amps is going to be a 12-volt drop, so this top here is 0 volts. Another way to realize that is by the inductor over here is a short, so it's short out to ground, so it's also 0. So VC of 0, really minus N plus here is going to be 0 volts. Now, let's double check that this I of t is really the same as the IL. Well, IL is coming down here, and I is over here, and it's in the same direction. So that means my I of 0 is going to be 2, which if you plug it into our formula, the E parts, e to the 0 goes to 1, so 2 is equal to K1 plus K2. Now we need to take a derivative, try to figure things out. So let's take the derivative of I prime here. So I prime t is negative 0.5 K1 e to the negative 0.5 t minus K2 e to the negative t. And what can we say about the derivative here? Well, let's see here. We know that the voltage across an inductor, if this is my VL and we have my IL, we know the voltage is L times the derivative of I. So we need to see what happens, the voltage across the inductor at 0. But the thing is, beforehand, at 0 minus, the voltage across the inductor was 0 because it's a short. But at t equals 0 plus, it's no longer going to be a short. It's no longer in steady state when the switch happens. However, we do know that there is 2 amps coming this way. We know there's 0 volts across the capacitor. Well, for a 3 ohm source, that means there's also going to be a 6 volt drop here, which means there has to be a 6 volt gain or a negative 6 volt drop on the inductor. So that means that the V is L di dt. So VL of 0 plus is negative 6. My L is 2. That means my I prime of 0 plus is supposed to be negative 3 from the initial conditions here. So I prime of 0 is negative 0.5 K1, negative K2 is going to equal negative 3. So now we take our system of 2 equations here and we need to solve it. We can actually just add down on that. K1 minus a half K1 is half a K1. K2's cancel. And we have 2 minus 3 is negative 1. So K1 is negative 2. Plugging that in, we're going to get K2 of 4. So then our answer for I of t then is negative 2 e to the negative 0.5 t plus 4 e to the negative t, and this is in amps.